like 11. Oh, thank you, Dan. So if you want, you can just post questions on the chat. I will try to look at those from time to time, or as we don't have too many people, so I think that it's okay if someone just opens the microphone and pose the question, and I will stop and describe a little bit what we will be doing. So let me start by sharing what we will be using today. So let's see. So the idea is to that we will be using a tool, software package called Spark in our cluster in Thornyflat from a web interface. So now very user-friendly graphic interface. So Spark is a tool for big data, for manipulating in principle, large amount of data, so big that you probably cannot do it on a single computer, even if with the examples that we will be using today are very small, kind of toy examples, that of course you can do it by hand. Of course you can do those with simple Python scripts eventually, or pandas, or other tools. But the point here is that the Spark is able to scale that to a very large amounts of resources, so entire cluster devoted to this. So we will be seeing this in practice step by step. So the first thing to do here is, let me see one question, is to, well, okay, Daniel that shared that with us. So go to that link, open on demand. So probably this is okay, but that will go to the same place. So open a browser and go to this website on demand. So this is a web application that will ask for your credentials, will ask for your password, username and password for that review. And you land on this dashboard, you land in this interface. So I will give you a couple of minutes so everybody reach to this point. If you get in troubles accessing the page, just pose the question. I will try everybody to be at the same pace on this, even if we will not be covering too much information. The idea is that everybody is able to follow this, and later on we can do more tutorials, more mini workshops covering the machine learning part or things like that. But at least if everybody is able to follow the materials today, that will be good enough. And of course, yes, you need to have an account. So if you still don't have an account on Thorny, this is a good opportunity to open a ticket for opening the account. You can do those things if you want on your own home computer. So it's okay if you install it on your own. But Spark is a kind of relatively complex machinery. So for getting a Spark, you need to install first Java on your machine. On top of Java, you put the Spark. And as we are using here PySpark, so when you install Spark, it will come with PySpark. But we will be using this from a Jupyter notebook, so also you need Python Jupyter installed. So a bunch of things that we will not be covering today, how you install those things. They are relatively well documented in the Spark documentation, but anyway. So I hope all those who have an account with us are able to reach to this point, get a page that will look like this. So the first thing that we'll be doing is copying all the materials that I prepared for you today from a specific location on the machine to your home folder. So for that, you click here on clusters, and after you click here in Thorny Flat shell access. So a new tab will be open, and on that time it will open like a terminal, and here you can type commands. So the command that you will be typing is this: all the materials have been shared, software, mini workshops, Spark Python. And I will copy all those materials to my home folder. So to the current location where I'm sitting. This is the command that you have to execute. So please take some time, open again. So here, clusters, Thorny Flat shell access, that will open a new tab here, and in this tab, execute this command. So I will be copying this. Let me see if I can do it. Yeah. So I copy the line on the chat, if you need. So all this, what it did was to copy an entire folder called Spark Python on your home folder. So you have your own copy of this material, and you can open the notebooks, the data with the data is there when opening the shell access. So right here. So let me see here. Imagine that I will be killing this, and I will be doing it again. So
yeah, I was asking that question to Rohit. He had an issue with it right above where I said that.
Okay. So let's recapitulate. You go into this website on demand, TF HPC WDU. So this is the website for our open on demand service connected to Thorny Flat, to our cluster. And after you authenticate with your Duo, your cell phone, your username and password, you land on this web page. On this web page, you click here in clusters, and you open a new terminal. So it will open something like this, your equivalent username here, and you just execute this command. We'll copy all the materials there. And after that, you can close this terminal if you want to. It will be disabled after a few minutes anyway, so it's okay. So we do this. So now, the next step is to start an interactive session on the cluster. So the cluster, an HPC cluster, is an aggregate of many machines, and you can request an amount of time, an amount of resources on those machines. So in particular, we will be requesting a few cores on one machine for 4 hours. So we will have enough time for covering the material that we will be presenting today. So you click here on interactive apps. So it's right here, interactive apps. And you go down here and click in Jupyter official images. So those are Singularity images. The important thing is they contain the software already prepared for you for the kind of applications that we will be using today. So here you land on a formulary like this, and here you select this one. there are a set of notebooks here, all of them data science related, data mining related. So, but for our purpose, please select this one. So it's called Jupyter Notebook Python Spark Stack, PySpark dash notebook. So that's the name of the notebook, the image that we will be using. Here you select a standby. So this is the queue, and in a HPC cluster, one important concept are queues. So those are locations where you can request access, same way as you can go in a supermarket for different queues, one of those for small purchases or fast queues, and some other for normal purposes. So this one is a fast, relatively fast queue where you will get running pretty quickly. There are many machines that are capable of taking jobs on this queue, so that will be moving fast. So standby. Okay, so now, how many hours? So you can request up to 4 hours here of execution on a standby, no more than 4. Next thing, how many GPU cores? So we will be actually doing very small exercises. So 3-4 cores, and I will not be so demanding, just in case that many people among us will be executing this. So 2 cores is okay. On our cluster, most of the compute nodes have 40 cores on each machine. So you can request all those 40 cores. If you are dealing with a lot of data, if you would like to process that massively, one of the advantage of Spark is that you can take advantage of parallelism and put all those cores to work together in the okay. So I will be requesting a couple. Feel free to request 3, 4. Try not to request the whole 40 because other people could not get jobs allocated fast. So that's okay. Forget about GPU cards. We will not be dealing with GPUs for this tutorial. Here you can leave this as it is, Jupyter Notebook, and you click here on launch. So again, let's recapitulate. Jupyter, this one, PySpark notebook, standby, 4 hours, 2 cores, 0 GPUs, Jupyter, launch. So you land on this page where it says all the jobs that you have on the machine currently. After a few seconds, you notice that you get, it changed the page a little bit, and you get, okay, you request 1 node, 2 cores is running. This is the name of the machine, and how many hours do you have left for executing your material. So now what we will be doing is click here on connect to Jupyter. Okay, and you probably have more things. I cleaned my space recently, so if you follow the command before and you copy the material to your home folder, you will have this folder when you click on Open Jupyter, Spark Python. Inside the Spark Python, there are 3 folders. One of those is called Notebooks, and we will be opening that one. And now we will open in the first notebook, and now for real, we will start learning about Spark. Okay, so I hope everybody has been able to open.
We have a couple people who are having problems with the shell access through on-demand.
Okay.
I know that thing has had problems in the past, so it might be, since all you're having them do is just copy files using that, right?
Yes.
Yeah, it might be best for anyone who has problems with that to just go sign into Thorny like you normally would and copy the files that way to avoid using that shell.
Yeah, there is another way eventually to see, but this could work. So even if you execute this and you don't have this, you still don't have it. You can click here and open a terminal in a different way, slightly different way. And from here, I think you can copy the data exactly the same. Share software. Let me see if I can do it. Oh, sure. Oh, 20. Okay, this way. Mini workshops, Spark, Python, like this. So this is another way of doing it. So CP-R, it will work. So let's recapitulate what I did. Imagine that you have been problems with that, but you request the interactive job. You get something like this. You are able to connect to Jupyter. So you just click connect to Jupyter, and you have a web page, a new tab like this. You click here on new terminal, and here it will open a terminal in a different way, and you execute this command. Same thing. Not this one. Not this one. I think it will not work this way. It's GPFS 20. Yes, like this. So in a slightly different location, the materials can be found, and it's exactly the same. It's exactly the same. So this is an alternative. If that works for you, it's perfectly fine. You are doing exactly the same.
So I don't know if you want to bother fixing it or not. It's not that important, but your camera's been frozen for a while.
You can what?
Your webcam has been frozen for a while.
But my terminal, so
yeah,
what I'm showing is okay?
your screen is fine, so it's not
my
that
screen
important.
is fine. Just my web, I don't care if.
Yeah,
I can see the webcam. His webcam is clear.
Oh, okay. Well, it's just me then.
Okay, okay. So we are here on notebooks, and let's open again here. So I hope somehow you will able to copy the material for you, so you have it. And now let's start learning about Spark. So it takes some while until we get everything in place, but now we can learn what Spark is, Apache Spark. So notice that we will be just this to show you a little bit that we are running on a computer that offers 40 cores, but from those, I just request, I don't remember, a couple, 2 cores from that. But most of our machines, all those that doesn't have GPUs attached to them, they have 40 cores. And eventually you can request all those 40 cores. With a little bit more strings and configurations, you can also request multiple machines, all those cores in those machines, probably 200 cores. And again, configuring properly Spark, you can use Spark for processing the large amount of data with all those cores on all those machines in parallel. So that is one of the big advantages of using Spark. So that's it. We are using a relatively recent version of everything here for Spark. Spark. So now let's see what the Spark is. So Spark basically is a data processing engine. It's everything about data. The idea of what is important behind Spark is that it was created with scalability in the design. It was created to scale to many machines on all those cores in those machines for processing data. So in contrast to other tools that are similar at some point in the kind of things that Spark is able to do, like scikit-learn for machine learning or pandas for data analysis. Those tools were not designed for distributing the data across multiple nodes. So that's a limitation for those packages. But no, Spark is able to scale that up. It tries to put as much as possible in memory. That's another important feature of the system. In our cluster, most of our what we call small memory machines, all those small memory machines, our definition of a small memory machine is a machine with 90 gigabytes of RAM. That is our definition of a small memory machine. We have machines with 180, 180, 200 something, and up to we had a few machines with 700 gigabytes of RAM. So that means that if your data is big enough and requires that amount of RAM, Spark can take it and will try to do the best to accommodate that in memory if possible. And we will see about persistency and caching in a minute. So we will get a little bit deeper on what it means. So Apache also provides like a general programming model for manipulating data. It means that it gives you a set of tools beyond the core of Spark. For example, tools for machine learning, it's called mLib, for data that is coming, that is streaming, like imagine data that comes from sensors, atmospheric data that is in processing, social networks, that sort of thing. So they have a special module for dealing with that kind of data that is flowing permanently, and also some extra capabilities for to get closer or put more structure on what the Spark is capable of doing when the data has a little bit more structure inside. So we will see that in the next notebook. So on top of Spark, so Spark, as it was built, it was developed in Java and a language called Scala. So Scala works on top of Java. So the main language for Spark are Java and Scala. And let's say the third one member in that at that level is Python. It's a popular language for working with data for scientific purposes. So that support comes in the form of something called PySpark. So PySpark is a layer that is capable of, from Python, use the Spark capabilities, the Spark features. So also PySpark give you access to some of the modules that I just mentioned. So the mLib you can use it from PySpark, the Spark SQL, the data frames that we will see in a minute. All those are tools that you have access from Scala. There are a few things that are Scala specific, that if you want to go deep or you want more performance, in certain cases, you need to move out of PySpark and program directly on Scala. But for what we will be doing today, PySpark is just fine. Is what we will be using. So now, by the way, see if you are at this point, you can execute. So we can start executing our first Spark example. So the first part here is using this tool. This is specific for Jupyter notebooks to be able to activate the Spark environment. So this is, let me see if I did it. Well, you can execute this again. By the way, for the executing in a Jupyter notebook, for those that are not familiar with Jupyter, what you do is you press Shift and Enter, Shift Enter. So you go here, you execute Shift Enter, and that box of code will be executed. So that is this first part will be enable the ability of Jupyter notebooks to the IPython kernel to be able to detect PySpark when we execute it right now. So now we are capable of importing PySpark. So we'll see PySpark. This is a recent version of Spark. So we are using 3.2. I noticed that in the official documentation, there is now 3.21. So we are pretty close to the most recent version of this. So now, there are two objects that are central for Spark. It's the Spark configuration. So this is something that you always load at the very beginning, the Spark conf and the Spark context. This is the point of entrance for everything that you do on Spark. And after that, it's in the Spark context that allow you to create what we call RDDs. We will see that in a minute. But at least you load this couple of objects here. And I will be creating my first configuration here. That this is what this says is, okay, I want to create, to prepare a configuration where I will creating an application that is called Gutenberg. We will see what I choose this is the word. And in this application, I will be using probably just 2 cores on my local machine. So that is what it says. And then before I was running with, let me see what I did. Probably because I already created, I already ran it. What I did. Okay. Still what I did. Okay, probably I executed twice, I generated. So now, then the next step is to create an Spark context with that configuration. Again, and the Spark context is the point on the door for creating the objects that the Spark is capable of dealing with. So, so here on this folder, and we saw this here, here on Spark Python, I put in place a few files. So all those files here with a number, those are books. Those are books that I download from the Gutenberg project. So this one, for example, and you can see a little bit the size of them. They are big, but not for today's standards of computing. But anyway, so they have like Shakespeare works, and here I have Thomas Aquina's works, Moby Dick, some big books. I pick a few big books. You can change, try if you want to explore a different book. Feel free to do that. So I put those there. So the books, And I will be opening a particular one here, this book, which is the Summa Theologica from Thomas Aquinas. So I will be reading this. So when I execute this, notice that SC is an Spark context, and this method here will read this file and will create what is called an RDD. An RDD means a resilient distributed data set. Is one of the basic objects in Spark for dealing with data. One of the core objects. It doesn't expect to have any structure, so it's reading a book, so it's just a bunch of text with not much structure. So here, what it reads are just lines of text, bunch of lines, and so it's actually having some lines of text. Actually, I can do this here, so I can create a new on here, and I can interrogate with this action. We will see the concept of actions here. Some of those lines here. What is the content of that? So lines.take. So you see that every element on this RDD is just a line. It's just a line of text, no more than that. And here I'm looking at the first 10 elements of that. So now we will be manipulating the data, manipulating that RDD. So we will take in the RDD and we will transform the data. What is how do you open a new executable? Oh, yeah, okay. It's like this. So imagine that I'm here. So they have shortcuts. I just know those, but let me see if I can show you the shortcuts. Keyboard shortcuts. Yeah. So what I was using was B, that should be around here. Yeah. A and B. A, insert a new cell on top. B, insert a new cell below. So that is the idea. So let me do it again. So here I did. So here I'm having this, and also notice that there are two modes on a Jupyter notebook. When it's blue, I am like outside, and I can manipulate and I can create new cells. But I can also be in edit mode. It means that I can introduce text inside the cell. Those are different. And you notice that when I start introducing text here, it changed from blue to green. So those are two modes. If I want to leave from that mode, I just execute escape, the escape key on my keyboard. It became blue here. And I now can, for example, create a new cell on top. Or here I can create with B a cell below. So that is the idea. And I can delete with DD a cell. So that's how you create a manipulate. Say, by the way, all those things are here. I think keyboard shortcuts. There are ways, or you can go here, I think, you can create a new one. I'm just used to this. Also, you can split cells. You can, one cell, you can split it and create multiple cells if you want to separate the content of it. So that's it. Let's execute it again. I create a new RDD here. And now, again, lines is an RDD, and we will be manipulating the data. Manipulating the data means we will transform the data. Transform in Spark means create a new RDD. So this RDD called lines will receive this transformation. This transformation is a function, and a very easy way of creating functions in Python is via the lambda function. The lambda function is a function that is so simple that even this doesn't deserve even a name. So it's just something that takes a value, do something with the value, and whatever it returns that, it will be the output. So that is a lambda function here on Python. So this is what I'm creating here. I am taking that, all the lines there, I am splitting all those words there by the spaces in that. So just taking the words will create a list of strings, a list of words. And this transformation will create a new RDD with all the words in the text. So we will see that, how that works. I will actually do it right here. So let's see if it works. So that's something that you do all the time. Let me show me the 10 first elements in that. So those are just the words, the text. Okay, so let's see. Now we can execute another action, counting the words. So how many words it detects on this text? So this is the number, 500,000 of those. And now I can execute this one, for example. And let me see if I can execute this. So it will show you how many times a given word was present on that text. With this action here, this action. Now this transformation. We will see the difference in a minute on those two concepts, transformations and actions. Here I am getting, oh no, sorry, no, this is an action. This is an action. What I'm getting here is just a list of tuples with elements, counting the number of times that a given word appears on the RDD. So you see here how many times the different words are there. So Thomas is 5 times, and a book, or this one is or like this, or appears too many times. So that's it. That does. So that is a summary of many of the things that we will be describing in a minute. So how to create an RDD, how to execute transformations that create new RDDs, and how execute actions that will process the data on top of those RDDs. So now let's explain more in detail what every one of those elements is all about. So RDD means a resilient distributed data set. Is the core abstraction in Spark, the lowest level for data manipulation. So lowest level means it doesn't request too much structure on the data. So a list of objects, things, is just enough. Just a collection of data. With those, you can create RDDs, either because you have the data on a file, or you can create it by hand, and we will see that from a list of numbers or values, whatever. You can create an RDD. You can transform an existing RDD and create a new RDD, transformations, or operations to compute a result, and those are called actions. We will see that in a minute. So those are the names, transformations and actions. They are central for working with RDDs. So here we will see this words here is the RDD that we create here on top. So we will be using those in a minute. So here, this RDD was created from this other RDD, lines. And lines is an RDD that was directly created from the contents of a file. So now what we'll be doing here, let's see, I can compress that. And you can double click on the output and if you want to compress it and hide that if you want. So here, I am applying this filter. which is a very popular transformation, where I'm looking for all placings, for all elements in the words where house is the line. Actually, this is not a line, it's a word. I just put the name here. So I can see a few elements of that. So this lambda function doesn't care if the line is singular or plural. If this word is in that string, no matter how, it counts. So you notice that sometimes appears here in plural with some other semicolon here. So the word house is in that string, so it counts. So now I can execute this action and see which is the first instance of that RDD. And we will see again deeper and deeper on transformations and actions as we progress in this node. So creating RDDs. Usually RDDs comes from files that you have, CSV files, Excel files. It could be something even larger. It could be entire databases. It could be multiple files and you aggregate those correctly. But also you can create simple RDDs just from a list of numbers. And that's what we'll be describing a little bit here for playing with the data. So here, again, this is what we did before, using the work, this book here, to create an RDD. That's one option. You can also use this method, parallelize, to create a new RDD from just a list of numbers. So this is a mini RDD. It has 3 elements, and the first element is 1. So you see. Also, we can use NumPy. NumPy is the core package for numerical operations in Python. So you can use, for example, a NumPy array here with random numbers, 100 random numbers. This is what I'm doing here. And use the parallelize method to get a new RDD with those numbers, from those numbers. So here, if I count that, of course, I got 100. And this one is the first element in that array. And also, directly from pure Python, this one, which is not a list, at least not in Python 3, just an iterable, you are able to get that converted into an RDD. So you can request that, and you could request the first element. This, by the way, is an iterable, so something that in Python you can iterate. Start from 0 and end on 999. So this method is very handy when you are creating small data sets, for playing and exploring a little bit what you would like to do. And this one is another alternative for reading from files, from text files, without expecting any structure of those files. When this scales, and we will not be using this for this simple tutorial, it's expected, for example, to have to run this on a machine that has distributed storage. So all the compute nodes are capable of reading the same files on the same places, more or less. So in our cluster, we have a file system, a distributed file system called GPFS. So the data is visible for all the nodes in the cluster. So that's one thing. If you scale this to the cloud, there are alternatives to this, like Amazon S3s or other entities where you can do something like this, distribute the data. There are some other solutions for scaling that higher. So now, transformations. Transformations are operations, manipulations that you do on RDD in order to get another RDD. We saw one of them, filter. This is one transformation. This just uses a function that you provide. It could be a lambda function. It doesn't need to be a lambda function. It could be a more complex function that do a lot of operations, do complex statistics, doesn't matter. But at the end, it returns true or false, and it decides if the value will filter or not for the next RDD. So here, again, we are using this RDD called words, and we will filter in it with this lambda function. And we are just asking if that word in this RDD that contains all the words in the book starts with the lowercase h. What we get are a new RDD. Nothing has been done at this point. When you execute this, Spark is not reading the data and looking for the right way. Everything is relegated for when you call an action. We will see this. But now we will be calling an action. Now Spark will check words as an RDD and start taking the values to fulfill the request of getting the first 10 elements of the RDD. So this is what I'm doing here, is checking these words, filtering those with this function, and it will take the 10 first. If this file is huge, it will not process everything else because take is just happy to get the first 10. So it will not waste time traversing the whole file or the whole data. It will just do what is necessary to produce the output that was requested. So this one, this list of values, period. Now, if we are asking for count, of course, it needs to explore the entire file and we'll get how many words in this text start with the lowercase h. This is our first transformation. Another popular transformation is a map. A map takes a function, and whatever it returns, it will be used for building the next RDD. One example. We create here an RDD with random numbers. 1,000 random numbers. We will be counting how many they are. Of course, we have 1,000 here. And this RDD is taking every single one of them, is injecting that as the argument for this lambda function. And this lambda function is returning 1 if this random value, which is between 0 to 1, is larger than 0.5, it will return 1. Otherwise, it will return 0. So it's basically rounding that up and down. This is the map. Again, nothing has been done at this point. Even if this is so simple that it will not make any difference. But now, this new RDD has not been evaluated yet. It's just the recipe for getting it. Only when you execute this, you get the first 10 elements. It will execute that for the first 10 elements and stop. Now, we can also call functions. It doesn't need to be a lambda function. A lambda function is a simple way of expressing quick functions, but it could be also a function that you apply to objects in the. So remember that these words are all the words in Thomas Aquina's Summa Theologica. So this function is returning a new RDD with the length of every single string on this file, on this RDD. So let's see, execute this. Those are the first 10 elements in my previous RDD. And here, I'm not executed anything yet. Only when I execute this, it will start taking in consideration every single word, at least the first 10. The first 10 will collect those, get the length of that string, and return that. And you can see that matches the lengths of those strings here. So this one, you see it here, 2 characters. Here is 2 characters. So those are. So now let's start with one example that I will give you, and this will open the opportunity for you to explore the first challenge that I have for you during this mini workshop, which is related to this. So here, this is a text file that contains information about airports around the globe. I don't know if all of them, but let's assume that they have all the airports, at least international airports around the world. So this is how I create a new RDD using the method text file. And this is my new RDD. Let's see what it has. Notice what it has. So, every single element that, and again, I am using this. So text file is not taking in account that this is a CSV file. No, just a text file, lines, doesn't care much about that. So, so this is the content. Just every element is just one string, one line. You are looking here at the first 10 lines in that RDD. They have this structure. So they have the airport ID, the name of the airport, the city that is served, country codes for the airport, latitude, longitude, altitude, time zone, DST. I don't know what the DST is. Daytime. Okay, I imagine that is something like the standard time, and the time zone. So that's what is there. So now the first part is here. Is we receive this and we will start giving a structure to this RDD. So we will. You can think naively, okay, I know that this is a CSV file, so let's split this with the commas. Okay, let's try to do that, split this by the comma. But that's actually a bad idea in this case, because some of those have a city name, which has a comma inside. So you will see that here we have 12 columns. So if we do this, and that is supposed to be working fine, you should get all those elements with 12 columns, which is not the case. You can see one, okay, this one is working okay, but there are a few cases here, those here, where comma is part of the name of the city. So that will break the rule, at least for, I don't know how many, but there are a few that break the rule. So we have to use something that's slightly different. This is called a regular expression. This is beyond what we will be covering today. Regular expression is a whole topic. But this very cryptic, weird string is capturing, separating the elements on each line with commas, not taking in account commas that are enclosed in quotes. So a quote here, a quote here, considering everything. If the comma is inside there, it will ignore it. And this is called a regular expression. It's part of the standard library in Python. So that is what I'm using here. this comma, then, and I am using that in a lambda, this good lambda function to separate the data. So let me see, yeah, let's see. So I'm taking the line, I'm using this regular expression to split the line correctly. I am taking just those elements where the third string after splitting is United States. With this, I am building a new RDD just with the airports in the United States, which is the problem here. So this is the regular expression process. This is a new RDD. Again, so far, nothing have been processed yet, and not least for this USA airports. Now, I will create a new RDD where I'm just extracting a few elements of this data. Just the name of the city associated to that airport and the code for the airport. So this is a function that I will use here in this map. Notice the map receives a function. I'm not longer using a lambda function because this is a little bit more complex. So I am creating an entire new function here, which splits the data again, and takes the second element, remove the quotes, takes now this is the third element. In Python, elements start with 0. So this is the splits. Number 2 is the third element. And this is the fifth element. And removing the quotes, so getting what is left here. And I will show you the first element. So notice that I'm getting the name of the city associated to the airport and the IATA code for the airport. So we can check here that we can see if the airport in Pittsburgh is there, and effectively is there. It's part of this RDD. So now we will have probably, I will separate let's say 15 minutes, because otherwise we will not have time for everything. Let's say 15 minutes. Try to do your best in those 15 minutes to solve this small problem. In the meantime, I will answer questions if you have those. This is the idea. Consider creating this RDD. Again, you can copy and paste, you can open a new, so nothing prevents you from going here and creating a new notebook and start executing putting in place the code for it, for solving this. So the challenge here is relatively simple, is just recreate the airports, the RDD for the airports, and just consider the airports. Use the transformations that we saw here, map, filter, just to get the airports that are in the tropical zone. So it means that the latitude is between the Tropic of Cancer and the Tropic of Capricorn. So in this case, it's minus 23 and minus 23, all those that lie in between those tropics is the tropical zone. So I would like to extract just an RDD just from those airports. So I will give you a few minutes so you start playing with that. And after that, I will show you the solution for it. It's very simple. But if you don't want to do it, it's okay. And it's right here. If you just want to see the solution, it's the solution for our first challenge. So I will not spoil that for you, but so just give you some time and answer questions so far, or help you if you got stuck in something so far that we have been doing. By the way, I can take this opportunity just to spare time and to mention that this mini workshop was created like, let's call it an appetizer if you want, to another workshop that you can sign for. It is a workshop. So WVU is part of Exceed, and Exceed is an organization for that aggregate several supercomputing facilities around in the United States, and they offer training. So if you go here and you create your account there, you can click here on training, and in a few days, in February 16 and 18, they are offering a workshop on big data and machine learning. So they will cover in that. I can show you the programming. So they will be covered in Spark. I think faster, but more in depth that I will be covering. This is a very light introduction to Spark. So that's something, if you want to get deeper in this, a little bit deeper, so they will devote several hours to describing Spark, more functionality, more actions, more transformations, SQL, and machine learning, that I will not have time today for going that far. And also in the second day is today. It's February 16 and 18, and on the 18 they introduce machine learning. So they use Spark again for solving a problem in machine learning. They use the machine learning functionality in Spark for that. And in the afternoon, they devote time to deep learning. So TensorFlow, mostly focus on TensorFlow. That is what is covering this more in-depth training. So if you are interested on this, feel free to sign up for this, register for this training. It takes place online. It's like this one, and it's offered by the Pittsburgh Supercomputer Center. So this is one thing. And if you want, they have also, I think you can go here and see the materials that they have. Or if you just want the materials, is right here. So they already have posted what they use for the last one. So introduction to Spark. So they have here an introduction for Spark that is very well written. And also this one for deep learning, for example. You can check that app and see, or a very decent introduction for a couple of hours on deep learning. So let's see, we still have a few minutes. I will give you a few minutes to work on this. It's really simple. You can just copy and paste. Basically, you need to copy a few things. At the very beginning, something like this, you copy and paste this thing, and this one, all the basic stuff to get up to in a Spark context. So all those you can copy and paste as they are, and after you start making the transformations. So notice a few tiny little spoilers here and there. Notice that when you read this is on a string. When you split it, it will be creating a list of strings. So even if you see this, it's not a number, it's on a string. You need to convert this from a string into a number. This is one thing that you need to be careful about. Well, so I think that's it. It's not that complex. Oh yeah, same thing, different language. Spark Clear is Spark for R, and you can use it on RStudio. If R is the language that you are more familiar with, that is probably a better solution. The difference is that PySpark is officially supported as far as it's officially supported by Spark or Apache Spark, while Spark Clear is like a third-party project. So if you go here, Spark Apache, so go here. The language, the first-class citizen languages for Spark is Python, Scala, and Java. But okay, are considered like same, that's a level. So yeah, Spark R and Spark Clear, yeah. So
Hey, Guillermo.
yeah.
Well, since we're on this break, there's the two people who were having issues earlier. It's because they didn't have accounts on Thorny. I
Okay.
had them request it, and I went ahead and made them an account. So
Okay.
just to help them catch up a little bit, could you show them how you like opened up the Jupyter Notebook and?
Oh, sure. Let's go here.
Obviously, can't re-explain everything, but
yeah. So yeah, really quickly. So first thing, go into this website. Let's copy this and paste this here again. This website. First step, you do this. Now you have an account. Perfect. You click there, and it will ask for your credentials. You need your cell phone, Duo, username, password, and you land here. This is the first step. Now, copy the data. I show you originally how to do it this way. So executing this command, I will not execute it, but that is the command that you execute. I will actually do. Let me see. I will do it again. Yeah, this, and I will copy this also. Well, I got some extra word there. See, I can edit this. Yeah, it's just this first line. Let's see if you can. That line. That is the command that you execute to copy the material that is in a central location to your home folder, so you can manipulate, you can change the notebook, you can do whatever you want with that notebook and the data that that is associated with the text files that I just offered to you. So that's the next step. Copy the data to your folder. So you can close this. It's okay. So now, interactive apps. You go here, interact apps, Jupyter official images, and you create a new interactive job. Selections. Here, Jupyter Notebook, Python, Spark stack. By the way, for those interested in R, here is the R stack. Is right here, and this one includes everything. So Scala, R, Python is just there. This covers all. And they have another one here for data science. So they have here I have a collection of official images from Jupyter, especially in the domain of data science related things. So this one. Q to select, standby, easy to get, fast, 4 hours maximum. Standby. How many hours? 4. You can request the maximum 4. Number of cores, request as many as you need for the size of the data that you will be dealing with. Most our machines offer 40 cores, so feel free to request the 40 cores if you need them. All the tiny examples that I'm dealing with are just less than 1 million lines. So that's nothing. So I can read those with a couple of cores. One core even is enough. No GPUs, Jupyter, and launch. Notice that when you do that, you create a new interactive jobs. You can have multiple interactive jobs. I have that one here already open. That is the job that I was running before, demonstrating. So I've been using 1 hour of that job, and here I have a fresh new job with 4 hours left, and I can have as many as I need if the resources in the cluster are available for it, of course. That's the next part. And now, after that, you click in Connect to Jupyter, and you land in something like this, actually something like this, where you have your data and the folder that you just copied, the Spark Python. It will be there. You go here inside, click in the notebooks, and start opening the first notebook that we have today, introduction to. You clean this notebook, and it will open. Well, forget about this one. It will open this one. And now you can execute step by step, follow the idea, read carefully. You can do it on your own later, execute it, understanding what is every single step doing in this process. Up to this point, our challenge is right here. So now I will show you really quickly what the solution, one solution for this that I can offer you. Should you see, are more comments that actually code in there. So again, I am loading these regular expressions because I will be doing basically exactly the same thing that I did before. Math, this is because I am using the absolute value, because all that I need is to know that the absolute value in the latitude, positive or negative, is less than 23 degrees, something around that. So it will be in the tropical zone. That's the reason why I load the math module, which is part of the standard library. So it's something that every single Python implementation will offer to you. PySpark, the same in this Jupyter notebook, to able to pick up the Spark installation. Seeing here, I am using exactly the same. So we can execute this. So this with the regular expression, the import PySpark, the regular expression already compiled there. The two elements, initial elements for building in the Spark context, which is the configuration. I can put a name. The name is completely arbitrary. And here I am requesting 2 cores for the Spark context. So new, so now reading again the Spark content, the file, I'm building the first RDD. And now this function up to here is just copy and paste from the original notebook. Now it comes the new part. So this new function here is asking if the latitude that you provide me in the function corresponds to a tropical zone or not. So it takes the line, splits the line with the regular expression, takes the 7th value in the list of strings, which corresponds to the latitude. I am checking if the latitude, the absolute value is less than 23.43. So it means that it's in the tropical zone, returns true, otherwise returns false. That's what it's doing here. I am using a filter with that function to create a new RDD just with the tropical airport. Yeah, I run this one here, run this one here, and now I can count how many airports I have in this new RDD. 2,300 more. So now let's see a few of them. Another action in asking, well, show me the first 10 of those. So it will pick a few here. Just to check this, I'm checking if one airport from my own country is there. So I'm checking if this airport with this IATA code is there, and effectively this airport in Bogota, Colombia, it's part of the list. And here I am extracting with this function. I create a new function for making this map. This map will take every single line and just return a tuple of elements with 3 elements: the name of the country, the code for the airport, and the latitude, just to check effectively the latitude is a value that is under the 23 degree. So first elements there, you see many African countries are there, and that's expected. Sub-Saharan countries, all of them. Anyway, so that is the solution, one possible solution for this, for the challenge. So now let's continue. Let's explore a little bit more about more transformations that we can do with the data. Flat map. We use this flat map when we were reading the book before, so we use it here, and this is exactly what we did. The words. We took every single line, we split that line using the spaces, and now we are building a new RDD with all the words, aggregating all the words in the system. Let's see the difference between a map and a flat map. Once you see this example, it will become really clear. So I am creating here a very tiny RDD. Let me see, with words here. So I have like 4 elements, 4 strings here. This is 1 string, another 3, 4 strings. I build the RDD with, which is the first one, is this one. So now what happens if I execute map, just map? If I execute this, this is what I get. 1, the elements will be embedded in list. So it returns a list of lists. This is the effect of the map transformation. If the number of elements in the RDD has not changed as a result. However, a flat map will take what is produced by the mapping function, and expands that when building the new RDD. So it opens the list for all of them. In this terminology is flattening the array. Same terminology that we use in NumPy when we are doing arrays. You flatten the array and you build that in such a way that is just cutting the dimension of the object. Now we have 3 elements separated. It's just this. And now the number of elements in the RDD is 10, what we expect. So that is the difference between a flat and a flat map. So a flat map is a way to expanding an RDD into even bigger one. Now, more operations here. Just these operations that you can do with an entire RDD. There are a few. They are commonly used. This one, for example, this. Consider this example. Numbers, and we will be using the numbers because it became really clear when we take those. Sampling. When you read a file, when you read a big file, of course you are not able to operate entirely on it because of the size of the data. So a solution is to sample it. You should never try to just sampling. Okay, I will take the first 10 elements or the first 1,000, because you don't know if the first 10,000 elements are really a sampling of this of the entire data set. It could be just the first countries, and you are basically discarding all the variety of the data set. So this is actually taking a real sampling, randomly taking elements here and there from the beginning, from the middle, and from the end. And it receives a few arguments. So for this, so again, RDD1 is just 10 numbers. Here, I am creating an RDD, a new RDD, with replacement. With replacement means that when you take one element, imagine that you put the element that you took back. So the next element, the element could be repeated, could be picked again in the next iteration. So that creates, like is the case here, repeated elements on this. An alternative to this is with false. It means that the first time that you pick the element, the probability of picking that element, of course, is 1 in 10 in this case. The probability to pick the second element is 1 in 9, because now you have 9 elements left on the list. The first element is no longer marked for being picked, it's discarded, let's say. So now, in this case, we will not have repetitions. You should not assume that the RDD, especially for those very tiny RDDs, will be actually, let's say, if you can have 10 elements and you ask a fraction of 0.9, that the RDD, the resulting RDD, is actually 9 elements, so 90% of the size of the original. Because what it's doing is actually taking the probability on this element to be picked, this element to be picked, this element to, it could be all of them. Pass the rule and you can get the 10 elements. No. So, but in large numbers, it will asymptotically and get in what is expected. So if you have 10,000 elements, well, then we will get roughly 9,000 elements in the sampling. So that's the difference between with replacement and without replacement. A final element here that is optional is to add in a seed for the random number generator that this machine uses to pick the elements. That's one. Distinct. This is another operation on the entire RDD that just pick elements that are different. Notice that this is a very expensive operation. Imagine that you are dealing with millions of points. If you are taking distinct elements, you need to traverse the set just to picking and removing all the duplicates. So use this with care. It's not supposed to run it. And if you can survive what you do, the statistics that you need to do, it's okay with dealing with duplicates, better not to run something like this. So what I'm doing here is I'm creating a random number of digits from 0 to 10, 0 to 9, or 100. I am taking the first set, and if I ask all the distinct elements, is traversing the whole RDD and returning, of course, that all the different elements are the 10 digits in the system. So this is another. This one is expensive. This one is not expensive. So take that in consideration. Union takes two RDDs. Imagine that you are reading files from different sources and you would like to aggregate those. So Union built a new RDD from the union of those. Union is just the aggregation of elements, not in the mathematical sense, where the union will exclude those that are already in the intersection. So it will be taken account once. No, here they will aggregate all. So if you see here, I'm creating an RDD from the first 10 digits. And now I create another RDD from 20 to 29, including and when I build the union, I get the first one plus the second one. Again, collect is again an action that is expensive. And I can only do this because those are really tiny RDDs. You should never expect to collect data that is terabytes of data because it will not fit in memory. So you cannot build the object, the resulting object from a collect. So in those cases, it's better to do a sampling or just take pick a few elements. Intersection, same thing. I am building a couple of elements, 0 to 10, 5 to 19, and building the intersection will return just the elements from 5 to 9, which are the overlapping sets between those two RDDs. So what do we expect? Subtract will remove the elements in the first RDD that are present in the second RDD. So here, first RDD from 0 to 9, second RDD from 5 to 19. And so when I execute this, it will return just the first part. So the 0 to 4, because 5, 6, 7, 8, 9 are also in the second RDD, so they are subtract. And Cartesian elements here, it will make a Cartesian product of two RDDs. So here, another RDD, they collect, and I will get tuples of all combinations of the elements in the first and second. So you will see here 0 combined with the numbers 15, so in here with this. So now actions. Let's review a little bit the actions. First, just the first element. So I will not waste time here with examples. Take, we use it a lot, just a certain number of elements. Count, we use it. Give me the total number of elements in the system and in the RDD. Collect will take all the elements and try to build an object, a Python object in this case, a list or something, with the collection of the RDD. So it only works if you are able to put that in memory. And reduce, which is another interesting, at least deserve an example, is applying a function to pairs of elements until you exhaust the list. So they will go in cascade, operating on a function that in principle is commutative and associative. So you can do that. You can traverse the operation across all the elements in pairs. So let's see an example here. One RDD here, 1,000 elements. The first elements, pure random numbers. Now, this reduce function action will take parts of them and will return the maximum of them. When that has been done, it will take new pairs from the subset that has been generated, and they will again operate in pairs to get the maximum of those new sets. And it will reducing the size of the set until you end up with two elements. It will compute the max between those and final two elements, and it will return the result at the very end. So that is what it's doing here. Of course, we will get a number that is really, really close to 1. And here we will return a number that is really, really close to 0. And here I am just adding the values. So basically, I want to add the values of the whole RDD. It's just taking, which makes sense because the values are between 0 to 1. So in average, they are 0.5, and we have 1,000 of them. So it's expected to be around 500, the final result. Another one. I didn't offer much of a small example of this one. Again, building tiny little RDD here with elements from 0 to 10, 0 to 9, 100 elements. So I can see the first one here, and I will create a tuple counting how many times every individual in this RDD is repeated. So, and it will return a dictionary here. So element 1 appears 8 times, element 4 appears 6 times, a key for the element, and the value of that is the number of times that the element was repeated there. So now let's review a few properties, elements of RDDs. First, they are distributed. These examples are so small that you can say, oh, I don't need that, distribute that. I'm working on a single machine, so who cares? But again, Spark was built for really massive amount of data. So distribution is critical to scale this up for large amounts of sets. The way it distributes this is taking the RDD and building in partitions. And those partitions are distributed across what they call workers. And those workers could be running on the same machine or could run on different machines. A cluster. You don't have interaction with that. That's something that is happening without you transparenting to you. So, but it's happening. So when we are doing this, it's not just one core that is working on the data. Multiple cores, 2 or 4, depends on what you said in the Spark context, that will be working on the data concurrently. So that is what allows Spark to scale. Another, and you notice this all the time in this tutorial, is the immutability on RDD. Every single time that we apply a transformation, we are getting a new RDD. We never change RDDs. So an RDD, once it's created, the transformation results in a new RDD. And those are not evaluated. So you see, when I execute, it goes, it's executed, it applies, but nothing happens, it's immediately, because that doesn't trigger a processing. It only actions trigger processing. So the RDD immutability is one important element. And the resilience. When you do this in large cluster, eventually one of the machines could fail. And that means that a portion of the processing could be lost. It doesn't mean that the entire processing is lost. Resilience means that the system is capable of taking what is is left, what is failed, and rebuild it, and rebuild the RDD if needed. If something is lost, it can be, it can adapt to that, and not having to recompute from scratch. And this, I insist over and over on this concept, lazy evaluation. Nothing happens until you trigger an action, like take, like collect, like what other action? Count by value of those. Those are actions. Only when you call those functions is that the RDD is actually reading the file, doing the operations, and execute. And I have one simple example to demonstrate how that is true, how that is happening. So this one is a book, or actually a file with the complete works from Shakespeare. So it's big. And you can request how many lines are here, and you see there. Now let's imagine that you make a typo here, and you try to open this. You execute it. It doesn't complain. It's okay. You ask for this new RDD that is filtering the first RDD. Nothing happens, no complaints. Nothing has been operated until this point. Only when I ask for this one is that I will get an error. And if you see the error here, it will say down, 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 down. At some point, I think, yeah, input path doesn't exist. So this file is not there. This error only appears when you call a function here. So Spark have not even tried to read the file, even checking if the file exists, until you call the function. Even this one that is just calling for the first line. So that illustrates very vividly how Spark works. What is the meaning of lazy evaluation? That only when you call an action is that everything is moving start moving in the system. Now, a little bit, I think that will be closing this one. I will probably have a few minutes for the next notebook, but not more than that. Let's complete this and let's see how far we can go, and we can arrange another workshop and get deeper and deeper on that. I would like at some point to reach the point, the machine learning, which is really interesting. Persistence. Again, Spark was built for large amount of data. It could be terabytes of data. It could be books. It could be economic data from many years, and trying to collect all that, trying to process all that. So it doesn't necessarily mean that you are able to read all that data and put it in memory. Even if you have a machine with 990 gigabytes of RAM. It looks like a lot, but at some point it will not be sufficient. So there are mechanisms in Spark to declare what to do with the data if I need it again. By default, if you trigger an action, it will repeat the process and execute all over again from the RDD in the next RDD, building the next RDD and getting the action. But you can indicate Spark that an RDD can be privileged to be cached or to store the data somehow, so new actions triggered on the RDD doesn't need to traverse the whole data all over again. And that is persistence. And you do that with the function persist. And there are several options for it. You can indicate memory only. It means that that RDD, the content of that, once the first action that call it, will store all that in memory. If at some point memory is exhausted, you don't have more, that is discarded, that portion that is not able to be stored on memory, and that will be recomputed again on the fly next time. That there is no reason why Spark will crash just because you ask memory only and the data is so big that it doesn't fit in memory. It's what to do if possible with the data, with the caching of that. You can also indicate that try to put as much as possible in memory, and if not, store it on disk. But a hard drive, no matter if you are using a distributed hard drive like we have on Sprue, which is very efficient and all that, and is built with hundreds of actually physical hard drives all working together on a data in a very sophisticated way, it is always slower than actual memory. So there are trade-offs. The only reason to justify this is if the processing, the mappings, filterings is so complex that doing that, all those again, is more expensive than storing the results in this, even with the penalty of having it in a slower device, in a slower storage device like a hard drive, or storing this only. So again, if it's so complex, so hard to get all that built, that justifies to sit on disk for future actions. And there is a small shortcut called catch. So you can take an RDD and say, this RDD catch. And that is equivalent to making persistent in memory. So there is no example that I can provide here that it makes this noticeable for those really, really small cases. So now I have time a little bit to describe RDDs. Probably for next time I will elaborate this. I will see what we can do if people is motivated for this topic of Spark, that data mining, data science, and we can arrange a succession of those workshops or not. We will see. Per RDDs. So the next level of complexity here is an RDD that at least have this structure of having a key and a value. In this case, just 2 elements. So a list of at least 2 elements. So you can operate with those. You can always take one simple RDD and build per RDD just by making a mapping where the resulting element is a tuple, the element and something, or number 1 or 0, it doesn't matter, 1. So you can build a per RDD. And there are a few functions that you can operate with per RDDs. So reduce by keys, group by keys, sort by keys, map. So a few functions that take advantage of that extra structure given to an RDD. Beyond this, there is an entirely different structure that is called a data frame. A data frame is, for example, the central object on something like pandas for Python. And so there is a close integration for that. We will see that in a minute, in the time that I have left. And many things in the Spark have been moving into a data frame as the core element instead of the RDD. For example, the machine learning structure is no longer introducing new features in the RDD base, but in the data frame base. We will see. Spark components. So far, all that we have been doing is around about the Spark code, the RDDs, functions, so actions and transformations, all that, the most basic layer. And I hope this lesson clarifies, I'll give you an idea of that, a solid understanding of that basic layer. On top of that layer, there is a nice set of features that is worth to mention. So Spark SQL for dealing with data frames. So a data frame is a more structured data structure where data with more structure. Think about it as tables. So they have columns, they have rows. You can put the columns names, and they have specific types for those columns. So the names and the types are called, it's called an schema. We will see that. We will see if I have in 10 minutes, I have time for showing a little bit of that. So they have more things. You can do more with data frames. Streaming, again, data that is coming permanently, for example, social media, Twitter, trying to capture fake news or misinformation or threats, all those things. So stream, or reading data from sensors, biological sensors spread in a jungle, capturing data. Some of them fail, some of them produce data. So all that, aggregating all that in real time. And the machine learning, which is really nice. This is, let's say, a step up on top of solutions like scikit-learn, which is the basic for small problems. MLlib scales that for really, really big data again. So here I'm describing a little bit the kind of things that you can do with that. I would like at some point to devote an entirely different workshop to machine learning with the Spark. The kind of things that you can do with it. And here I just put a couple of links for the documentation on Spark and PySpark, which is really good for those. I would probably have just a few minutes. If someone has a question, I have time for that. Otherwise, what I can do is at least introduce you to the Spark data frame, and you can at some point continue your learning using this notebook. This notebook is basically a slightly modified version of the same documentation in the Spark for PySpark for the data frames, because it's well written and is comprehensive, or at least it covers what I would like to see. So again, here, let's see, loading Spark, waterfront here, and here, and here. So a data frame. There are several ways of create a data frame. Now, small changes here. PySpark SQL. And now we are, instead of a Spark session, we are building a Spark. Instead of a Spark context, this is called a Spark session. So, and we get this here, create slightly different. Yeah. Other than that, here I just load pandas because I will interact a little bit between those two words, pandas, which is a popular library for data analysis in Python. And at some point closer in the structure to more natural language for this domain, which is R, for example, where the data frame is a natural entity. So pandas fills that gap somehow in the case of Python. So now, from PySpark SQL, I am importing this new object called row. And that is because this is one way of building a new data frame. Building a data frame from rows. So you declare a row with a certain name for the elements, and it will infer when you create a data frame. Again, think about it as tables. They have columns, and the different columns could have different types. So notice that the D column are all dates, the C column just strings, the B column is, notice this dot, so those are floating point numbers, and the A columns, the A column is just integers. So this is a data frame with some structure. It infers, I never said that, but it infers that A is just integers, B are doubles, C is strings, D dates, and E is timestamps. So all those are integrated there. Notice a difference between, for those who are familiar with NumPy, for example, that when you create a NumPy array, a multidimensional NumPy array, all the elements in the NumPy array has the same type. On the contrary, on a data frame, the different columns, different columns could have different types, but all the elements on the same column have the same type. So this is an important difference between NumPy arrays and the world of data frames here. So this is one way of building a data frame. This is another way. This is just from tuples. And here we're explicitly declaring the schema for the table for the data frame. So this is another way of building a data frame, equivalent. This one via rows, this one from tuples, and this one from a pandas data frame. You can create a Spark data frame. So create a data frame from, I'm building here a data frame in pandas. So this is a pandas data frame. And I'm using this one to build a Spark data frame. And you can go back and forth between Spark data frames and Panda data frames, except for the fact that Spark data frames can scale into sizes that are so big that you cannot go back and recover the Panda data frame, except if you filter it somehow or sampling. Or this is another way, just from more low-level Python elements, like a list of tuples. And this is what I'm doing here. I am using the parallelize for the Spark context associated to this Spark session. Here, a bunch of tuples, and here I am adding the schema at the end when building the data frame. So all those are equivalent ways of building data frames, and I can interrogate, let me see, the tables, to produce the tables with nice ASCII art, and the schema for them. So show me the table, show me the schema. I can ask for one single element, show one. And also, and this is just for Jupyter notebooks, I can enable with this, making this true, let's say a visually appealing tables where they look, they build like HTML file code for it and build tables inside the Jupyter notebook. And also you can here, I think, yeah, this one here, when a variable here, you can decide how many rows by default you want to expose on a data frame, similar to the elements that you can expose on a pandas data frame. That when you show the data frame, will show the first and the last elements and a few dots in the middle. So how visually you want to see that data frame. So here is another way of looking at one particular element in the data frame with the schema in the vertical, and that. Get the columns and build a sub table or a subset of the data set of the data frame with particular columns instead of the whole thing. So you select a list of columns that you want to see, and you just produce the data frame. And finally, again, expensive, if not necessarily possible, if the data frame is too big, you can ask for get the data frame as a Python list with rows where you can manipulate that outside Spark. So this is getting out from a collect. Same thing as we did for RDDs. You can take just one element. It will mean take just the first row. And here you can, as I mentioned, traverse, move from data frames, Spark data frames into Panda data frames, back and forth, so you can export something into a data frame. You can select one column, and again, this is again lazy evaluation. Selecting a column doesn't do anything computational wise, is operating. It's just saying, okay, yeah, you asked me for this column. Okay, I know, you take that column. And after, you can use that, all those elements here are just columns, they're not evaluated until you actually do something with them, like a selection, a show, or something where you actually are operating with one particular column. Or here, for example, where you take a column, a particular column here, and you make like a mapping where you create a new one, a new extra column with a new name, where you uppercase all the elements from the C column. So you take the C column, you uppercase all that, you build an extra column on the data. For example, imagine that you have this for data around the world, and you have the GDP column, but you don't have the GDP per capita. So, but you have the population other column, so you can take and build an extra column from that, where you are taking two columns, the GDP and the population, and computing the GDP per capita. That's the purpose of doing something like this. So the column, you just pick the column, but we'll only operate with it just when an action triggers that operation. So here, just one is picking, just filtering just one element, one particular element, and showing the row that satisfies that condition. I think I don't have much time. I crossed the limit, 3 o'clock. I think what is left is just a small set of elements here that I will need to cover in order to present later on in the next workshop on machine learning. So I am going in that direction of showing you machine learning processing with Spark, but I have to stop it at this point. So any questions, I can stay here for a few minutes if you have questions. Otherwise, feel free. Thank you very much for your attention. And see you next time. We will be having these kind of workshops regularly. So thank you.